तो a knife edge of mass m is dropped from certain height. तो यहां से जो है एक नाइफ एज जो ड्रॉप हो रहा है, और लेट अस इमेजिन दिस इज अ वुडन फ्लोर. ओके, ये वुडन फ्लोर है. एक नाइफ जो है अंदर जाएगा वुडन के अंदर, ठीक है, एक वुड के अंदर जाएगा. इट गोज इनसाइड द वुड बिकॉज एंड स्टॉप टू सर्टेन एक्सटेंट. आफ्टर सर्टेन एक्सटेंट इज गोइंग टू स्टॉप. यहां पर जाकर रुक जाएगा वो. ओके ओके, कितना डिस्टेंस जाएगा अंदर डेप्थ में? d डिस्टेंस जाकर रुक जाएगा. इनिशियल वेलोसिटी ऑफ द नाइफ क्या है? 0 है. ओके, एंड हाउ मच टोटली हियर? दिस इज गोइंग टू बी द हाइट एज. ये वाला हाइट एज एंड इट इज गोइंग इनसाइड टू डिस्टेंस d हियर. अभी देखो यहां पर व्हाट इज द टोटल वर्क डन बाय द बॉल टू रीच दिस और बाय द नाइफ एज. ओके, so knife edge is falling like this on the floor and it is entering into the floor because it is very sharp and because of resistive force it is going to stop. So here you can consider here what is the potential energy of the knife edge, what is going to be the potential energy of the knife edge. Okay, and that is going to be work done by the floor to stop the knife edge in the opposite direction. Okay, let the resistive force be Fr. Okay, in the opposite direction. So potential energy is counterbalancing and energy is conserved. It converts from one form to another form. ये वाला potential energy it is going to convert into work done by the wooden block to stop the knife edge. So potential energy कहाँ से कहाँ तक जाएगी? Because the knife is traveling h distance and next d distance. So we can consider it as mg into h plus d. Okay, and work done by the wooden block to stop the knife. क्या होगा ये work done? It is going to become mg into d here. Okay, mg into d. ठीक है, तो here or else you can take the resistive force is taken as Fr and distance is d. Okay, resistive force work done is equal to force into distance, but here he is asking us to find out what is an average resistive force. So this is going to be the resistive force. Fr is equal to mg h plus d by d, which is nothing but mg. Okay, h by d plus 1. So this is going to be your final answer. ये हो गया आपका final answer. The resistive force is mg into h by d plus 1. Okay. So next thing here we shall discuss. A uniform chain has a mass m and length l. It is held by on a frictionless table. Okay. So let us imagine there is one table here, and on the table, let us imagine there is a chain which is hanging. Okay. There is a chain which is hanging. Let 1 by nth of the part of a chain is hanging. Okay, तो इसमें से 1 by nth part hang हो रहा है, remaining part is resting on the table here. Okay, so now what is the work done here? Work done means mass of the hanging chain g into length of the hanging chain. Okay, so what is the mass of the hanging chain here? It can be taken as m by n. Mass of the hanging chain is taken as m by n. So what is the height of the hanging chain? See, whenever you are considering, यहाँ पर uniformly distributed body अगर हम ले ले, यहाँ पर uniformly distributed body अगर हम ले ले, तो हम क्या करेंगे? उसका जो है हम center of mass लेंगे. Center of mass का मतलब ये जो है L by n है उसका आधा. So L by n divided by 2, which is nothing but L by 2n. ठीक है? Which is nothing but L by 2n. तो अभी जो हमारा नया जो work done to pull the chain completely on the table, to pull the chain completely on the table is mass of the hanging chain m by n and g into height of the hanging chain. So the height of the hanging chain when you are considering, you are taking a center of mass. मतलब जो hanging chain है उसका आधा part हम लेंगे because it is a uniformly distributed body. तो हम क्या करेंगे यहाँ पर w is equal to mass of the hanging chain क्या हो जाएगा m by n, g height of the hanging chain क्या हो जाएगा l by 2n. So your shortcut formula is mg l by 2n square. So ये formula के अंदर यहाँ पर 1/6 of the part of a chain is hanging बोल के बोला. 1/6 means 1 by nth part I told 1 by 6 means n is equal to 6 here. So just substitute the value of n 6 here. So we are getting mg l by 2 into 6 square. 6 is a 36 into 2. 72 is going to be your answer. So mg l by 72 is going to be your answer. Next. Find the velocity of the chain when completely slips from the table. So let us take this as a table. And this is a chain which is hanging on the table. Okay, so after some time what is going to happen? Completely chain is slipping. Okay, so total chain is going to slip. Okay, so when this is part which is going to hang here, then what is the work done here? Just now I told you work done is equal to mg l by 2n square. This part. So when completely it slips, we have to take the center of mass here also. So we have to take just half of the length, L by 2. Because no chain is resting on the table, so therefore we can take W1 as this one and W2 as mgl by 2. That's it. Okay, mgl by 2. This is going to be the work done here. So completely chain is slipping down. What is this? This is going to be work done by gravitational force. Okay. So what is the final velocity here? So work kinetic energy is equal to change in the work done by the gravity to pull the chain completely to the ground. So work, the kinetic energy is taken as half mv square. The work done can be taken as mgl by 2, okay, minus mgl by 2n square. So you're getting here half mv square. Mg by 2 if you common out, 1 minus 1 by n square. So gets cancelled, 2 gets cancelled. V is equal to square root of g into 1 minus 1 by n square. This is your shortcut formula. Then what he is telling here, 1 by nth of the part is hanging. So if the part of the chain which is hanging is half, okay, that means 1 by 2 is nothing but 1 by n. N will become 2 here. Then what is going to be your answer here? So g into 1 minus 1 by 2 square, which is nothing but 4. Okay. So your answer is going to be how much? Square root of 3g by 4 is your complete answer. Okay. Square root of 3g by 4 is your answer.